Damian here from Cloud Technology Experts. In this video, I want to show you the process of deploying a microservice application in Docker and Kubernetes. And in the process, I will explain the differences between Docker and Kubernetes. As a technical trainer who trains on these technologies, Docker, Kubernetes, and microservices development with Python, I get asked these fundamental questions a lot, and hence I want to make the effort to explain them in this video. I have a blog written on this, so you can click below the video to get full access to the blog. This is the first video in the series of videos that I'll produce to explain the full process of managing a microservice in Kubernetes. The rest of the series are as shown on the slide. So I ask you to come back for the rest of the series. In this first video, I will explain why containers and why Kubernetes. Also, what is the difference between Docker and Kubernetes? This video assumes that you already know what a microservice is and that you're familiar with the architecture of Kubernetes. If not, please check my videos and or blogs to explain these concepts. The architecture of the microservice is as shown on the screen. This is called the voting app microservice that exposes two endpoints: the vote endpoint and the result endpoint. Users vote at the vote endpoint and then they can access the result at the result endpoint. When users vote, the votes are buffered through the Redis, and then a worker microservice checks for the vote, retrieves the vote, and then stores them in a PostgreSDB database for the result microservice to retrieve and display. Service demonstrates one attribute of a microservice, which is called polyglot, the ability of a microservice to be written in different languages, but all of them coordinating to perform the function that the application is intended for. All right. So now that we understood the architecture of the microservice, I'm going to perform two labs. The first lab is to demonstrate how to run this application using Docker. We're going to use a Docker utility called Docker Compose. The steps to perform this lab are highlighted on the screen. But I'll basically hop over to my lab and I'll perform this lab. After that lab, I will move on to the second lab. That will be done in Kubernetes. The same application that we run in Docker Compose, we're going to run that application in Kubernetes. So once we have seen how these two different applications perform, then I will explain the differences between Docker and Kubernetes, and then I will also tell you the reason why the two are very powerful. So let me hop on to my lab and show you how these applications can be run in Docker and Kubernetes. So I have two labs environment. One is called the Docker lab, while the other one comprises of a Kubernetes cluster. My Kubernetes cluster is of 5 nodes. I have 1 master and 4 worker nodes. So first, let me SSH to the Docker lab environment and do the lab for Docker. All right, so this is my Docker lab environment. I already cloned the application I'm going to use called the voting app. So cd voting app application. So now that I'm here, I'm going to use the Docker Compose utility. Docker Compose is a Docker utility that makes it easy for you to deploy a multi-tiered application. It helps you to connect all the pieces together. But this tutorial is not about Docker Compose. So if you want more details about Docker Compose, you have to either head to the website of Docker or wait until I do a video on that. But basically, we have a file here called Docker Compose.yaml. Here, the voting app is configured to deploy on this environment. To deploy it, just simply do Docker compose up. I'm going to put it at the background. And we'll wait a few minutes for the application to be fully deployed. Now we can check if our application is fully deployed by using a command called docker compose ps. When I run this command, you can see that I have all the microservices properly deployed. 5 of them are running. Remember, we have 2 endpoints. We have the result endpoint, and then we have the vote endpoint. So here's the result endpoint, and here is the vote endpoint. For us to access the vote endpoint, we have to use the IP address of this server, which is 192.168.0.13. And then we need to use this port number here. Docker has a way of exposing ports from the container into the host where the application is running. So even though this application is running on port 80 inside the container, we expose it on port 5000 inside the host itself. So for me to view this application, I need to go to my browser, put the IP, and then put a port, which is 5000. (192.168.0.13) port 5000. And that is my voting app application. So if you want to vote for cats, you just click on cats. If you want to vote for dogs, you just click on dogs. Simple. This is a simple microservice which is working as we expect it to work. So this is the vote endpoint. To see the result endpoint, we need to go to that same IP, but in this case, we can use port 5001. So let's create another browser. Let's go to the same IP, 192.168.0.13, port 5001, and that's the result. Only one vote. Sorry, only 2 votes. So we have cats has 1 vote, dogs has 1 vote. All right. So now that we see the result, how it works in Docker, let's hop onto Kubernetes to deploy the same application. I'm going to leave this one running. So I'm going to hop onto my cluster, which is on 192.168.0.7. So here's my Kubernetes master node. You see I label it here master 1. To see the number of nodes, I do kubectl get nodes. kubectl is used for managing a Kubernetes environment. So you can see right there, I have 5 nodes on this cluster, 1 master and 4 worker nodes. What do I do next? Now I need to deploy the application. Again, I have already cloned the repository here. If you are doing this, you need to follow the instructions. First of all, you need to clone this repository. So now I'm here, but I need to go to the folder for Kubernetes, which is this one here. So while I'm here on this folder, you can see that I have a lot of YAML files. In due process, as I go through this application, I will explain to you what each one of these files is doing. For now, I'm just going to use the kubectl command to create all the objects, the Kubernetes objects required to run this microservice. So I do kubectl create -f dot. Dot means all the YAML files in this directory. And then I wait for Kubernetes to create them. Okay, it says they already exist because I created them before. So let me delete them. That is how you delete your pods or your objects. Now let me do kubectl get pods -n vote. So I wait for them to get terminated before I create them again. Okay, everything clear. So let me clear the screen and run this command again to create them. All right, all of them have been created. So let me check that they're all running properly. So all of them are being created. Let's wait for them to finish. Okay, all of them are running. The next thing we need to do is we need to check the services, because we need the services to access these microservices. Now that we check the services, we have 4 services. But the one we're interested in is first the result. The result shows that it is of a type node port. Okay, and also the vote is of a type node port. There are different types of services. As you can see here, we have cluster IP and we have node port. If you don't understand what these are, you can go back to my previous videos. At the same time, during the course of this blog series and video series, you get to understand everything that a microservice is made of. So you're still going to understand what a service is, what a pod is, what a replica set is, and what a deployment object is. That will be the aim for this blog series. Now that we have the service running and that we know our services, since they both have the type node port, to access a node port in Kubernetes, you need one of the IPs of your cluster nodes. So when I do kubectl get nodes, I can do -o wide. So with this command, I have my 5 nodes. I can use any of these IPs to access this microservice application. The second thing I need is I need a port. The port is always going to be the second one. Usually this port has to be between 30,000 to 32,767,000. This is designated for Kubernetes to use. So I can use any of these IPs. Let me try to use this one. And then I can use 31,001. So let me hop back here, click on that, paste that, and then have 31,001. So with that, I see the result. But what if I want to see the vote? To see the vote, I can do the same thing, but I need a different port. And the port is going to be 31,000. So let's hop back on. All right, so now you can see I have the same application that I saw when I ran that with Docker Compose. Same thing. These two are with Docker Compose, while these two are with Kubernetes. So what does that show us? I've just used this to show you that this same microservice application can be run on both Docker and Kubernetes. The question then is, if I can run the same application in Docker and in Kubernetes, then why should I use it in Kubernetes, or how do I know which platform to run it on? So I'm going to explain when you need one or the other. So basically, if I come back to the slides, I've done lab 1, I've done lab 2, and you see the same application being created and shown on the dashboard or on the browser. So why Docker in the first place? Because that application I ran, that microservice, I can also run it on virtual machines or even on bare metal machines. But Docker is the best platform for several reasons. First, it is portable across different platforms. You see, these days people talk about a lot about hybrid cloud. People also talk about multi-cloud. So, as people continue to combine these different cloud platforms, you need an environment that enables you to run your application anywhere. So Docker helps you to do that. Docker is portable. It can port it to any environment and it can work with no issues. Second reason why you want to use containers is that they are really fast. They are blazingly fast. Do you saw when I created the microservice application? They took just few minutes, if not seconds, to get fully ready. And that is a full-blown microservice application. If it were virtual machines or bare metal, that would take much longer to get created. Finally, Docker is quite cheap in the sense that they have high density. Because they are light, I can pack a lot of Docker containers on a bare metal or even inside a virtual machine. So because I can pack so much inside a single environment, they work out a lot cheaper. You know, in life, if something is fast, usually you pay a lot for it. Docker is fast, yet it is very cheap. So these are some of the reasons why you think why Docker is so good. Why Kubernetes? Well, now our microservice application is running. We want people to vote. Now we want the entire country to vote. Let's assume that we are more than 300 million in this country. I want these 300 million people to vote. I tell you, when few people start to vote, that single virtual machine or bare metal machine will no longer be sufficient. You need to scale. You need to scale your application. More so, you want to be able to do that dynamically so that as more people begin to use the application intelligently scales to meet the demand. The problem with that is if I use just Docker, I cannot scale I cannot scale beyond one node. Why? Because Docker was designed to run on a single node. So if I needed to scale beyond or more than one node, I need something that can help me scale my containers across different environments. This is where Kubernetes comes in. This is where Kubernetes shines. Of course, you can use something like Docker Swarm to scale your applications. However, Kubernetes has proven its worth in the microservices market. So pretty much almost everyone uses Kubernetes. So Kubernetes is an orchestrator. It helps to manage the container on different environments, on different nodes. So you see, when I showed you earlier, I had a cluster comprising of 5 different nodes. But for Docker, it was just a single virtual machine. I SSH to that single virtual machine, then I created my application using Docker Swarm. Everything, all the microservices are running on a single node. With Kubernetes, not so. With Kubernetes, all of them are spread across different nodes. And I can go back to show you that briefly. So this is my Kubernetes environment. You see this command that I run here, kubectl get pods. Get pods minus envote minus o wide. When I run this command, it will show me the different nodes where my containers or pods, as Kubernetes calls them, are running on. For example, you can see that the vote is running on node 02. In fact, all these ones are running on node 02, while the last one is running on node 04. The scheduler happens to distribute them this way, probably because node 1 and 3 are busy with some other stuff. But the point here is all my microservices are running on different nodes of the cluster. So in Kubernetes, I have Docker running on every individual node. Like every one of this node here is running Docker. Then Kubernetes sits on top of it and help me to manage those microservices. Therefore, with Kubernetes, I can do a lot of things which I couldn't do with just Docker. So when I run the microservice, Kubernetes performs these operations. It does the scheduling of the containers or the pods to the different nodes, some to node 02, some to node 04. Kubernetes helps with the communication between the microservices on different nodes. It helps with the scaling. I can scale any of these microservices. For example, I can go ahead here and scale any of these microservices. For example, I can do kubectl scale deployment vote. So I just scale the vote microservice to 5 nodes or 5 pods. So if I say kubectl get pods, now I have 4 additional microservices, or rather additional replicas of the vote microservice that are running. See, very soon all of them will be ready. So you can see now I have the vote app, 5 of them are running. See how easy it is for me to scale this microservice. So as we proceed in these tutorials, you will see the power of Kubernetes. Okay. So Kubernetes, apart from scaling, can also help me with the security. I can manage the security of the microservices. I can do that within Kubernetes using different security features of Kubernetes. Or I can even do it from an external service like Istio Service Mesh. I can do the monitoring of my microservices. For example, if I kill any of those microservices, Kubernetes objects, deployment controller objects monitors them and make sure that it brings them back. So I can do all that. For example, if I hop back here to my environment and I delete one of these pods, let me delete kubectl delete pod. Let me delete the first one here. If I delete this pod, you see that immediately another one will be replaced. So wait for it to finish. By the time we go back, we're going to have the pod getting replaced. You see, so now we have it back. See the time? The time is going to be very different. Time is now 13 seconds. So that's a new pod that got created, 26 seconds. So as soon as I deleted it, the controller object, which is monitoring this environment, this pod, this microservice, discovers that you need to put another one back, and it did that immediately. So Kubernetes can also help me with logging. If my pods are having issues, I can log into them. I can check the logs on them. But also, I can use something like EFK Stack, Elasticsearch, FluentD, and Kibana. So basically, I can either use everything within Kubernetes or I can use an external service. Also, Kubernetes helps me with networking. Set up all the communication required for the pods to communicate, for the microservices to communicate, for Vote to communicate with Redis, and for Redis to communicate with the worker microservice, and the worker microservice to communicate with the database, and the database to communicate with the result. The environment, the networking required to make that happen is all set up by Kubernetes. We'll talk about that in this course as well. And finally, Kubernetes can help you with the volume management. Set up a volume environment so that you can create volumes and attach them to your pods or your containers. So these are some of the beauties, these are some of the things that Kubernetes can help you achieve in managing your microservice application. So hopefully by now you know the differences between Docker and Kubernetes. You know that Docker is used for running your containers on individual nodes of the Kubernetes cluster, while Kubernetes is used for managing your microservices across different nodes, which helps you to scale more than anything else. So, when you use the two together, they are very, very powerful in this modern day architecture called a microservice application. A microservice application comprises of a suite of loosely coupled applications. Each one of these applications is called a microservice. This is different from traditional applications that were normally called monolith, where applications get written in a single code base, in a single binary. But now, your applications are divided into a set of loosely coupled, independent, autonomous applications. So, this is the process you use to write a microservice, and we'll see how Docker and Kubernetes is used to manage them. So to write a microservice, first of all, you decompose your application into different components. Then you write each one of those microservice application. Then you package that microservice along with all the dependencies in a Docker image. Step 2. Then step 3, you want to repeat that process for all your microservices. That is, package them in an image with all the dependencies. Then you want to upload those images to a Docker hub or a Docker registry. You can use any Docker registry of choice, but Docker hub is the default. It is publicly available for anyone to use. Then after that, you can now select how you want to manage this microservice. Do you want to have your own Kubernetes cluster deployed in-house? Or do you want to use a managed service, like those provided by AWS called EKS, Elastic Kubernetes Service, or by Google Cloud called Google Kubernetes Engine? Irrespective of how you want to manage your environment, once you decide, you can now deploy your microservice application to that environment. And this is what I just did for you. I deployed a microservice application called Voting App to my cluster, comprising of 5 Kubernetes nodes. And now you can continue to scale and manage your Kubernetes environment. Great. So I've shown you everything I want to show you for this short video. In conclusion, again, Docker and Kubernetes are very powerful. They fit perfectly with a modern application architecture called microservices. Docker is a container runtime, while Kubernetes manages Docker runtimes on several nodes in a cluster. Kubernetes can be seen as a cluster manager, or what we call an orchestrator. It sends control messages to Docker runtime on several nodes of the cluster, of the Kubernetes cluster. So, both of them work perfectly together. Without Docker, or at least another container runtime, Kubernetes is not useful. And without an orchestrator, Docker is also not that useful. But when you combine those two services, those two software open source applications, you can have one of the most powerful infrastructure to manage your microservices applications. I hope you find this video useful. Again, feel free to read the full blog on this, and remember to come back for the rest of the series. Thank you for watching, and I hope to see you soon. Bye for now.